Good morning, everybody. We're here to talk to you about some network troubleshooting today. Actually start my slideshow real quick, that would help. First, I just want to ask you guys a question just to kind of get your minds going on the topic. What do you guys think of when you think of troubleshooting?
A flow chart?
A flow chart? What's the first thing you might do to approach it?
Unplug it and plug it back in.
Yeah, I guess that would be a good place to start. Anybody else?
Check your cables, connectors, and configuration.
All right. You guys are focused more on what the physical problem might be, but what if it's not even a computer problem?
We've got a theory of what's going on first.
Right. Yeah. First thing you might want to do is actually figure out what your problem is. Ask questions, figure out who's reporting the problem, and get them to tell you as much as you can get out of them. And then you also have to keep in mind that what they're telling you might not all be accurate or true, and you kind of have to take it with a grain of salt. And then as you're listening to them, you want to kind of establish a theory of probable cause. A lot of times you'll actually have multiple theories of what could be your potential problem. And you're going to want to test one theory at a time to determine what the problem actually is. And then once you finally figure out at least what you think the problem is, you want to establish a plan of action to start resolving the problem itself. And then after you've made your plan, you want to go ahead and start implementing your solution, verify everything works. And then after that, you make sure everything is working and perfectly good and fine. You want to start trying to implement preventative measures. That might be something like educating your users. It could be something like installing new hardware, software, updates, anything of that nature. And then when you're finally done with all of that, you want to document the process. Hopefully you're doing this a little bit as you're going. You want to make sure you document thoroughly what the problem is, what the solution is, and what steps you took to solve it. So again, you want to identify the problem and consider that there could be multiple. And you want to observe the user as they're reporting the problem, because you don't know how technically experienced they are, or maybe it's not even a technical problem that they're having. But you just want to kind of figure out how much do they actually know what they're talking about. And then you want to use any kind of tools that you have available for you. And this could be, like your cable testers. It could be some software scanning something or other, but anything of that nature that can assist you. This is all used just so you can gather more information. You want to look and see with your own eyes as well as what you're hearing from them. And you want to try to duplicate the problem to see if you can, kind of pin it down. Determine the scope as in how widespread is the problem, who is it affecting, because that can also help you kind of identify where it can actually be, whether it's just a localized problem of just one system, or if it's a more widespread problem like something your ISP has going on. And you want to establish timeline and change. I know Mr. Hamilton talks about that quite a lot. It's super important to know when and what happened, because then you can look at logs and look at those exact times and see maybe what happened if you were unable to actually figure that out. If you think it's a physical issue, consider checking the cameras, because this could actually tell you if somebody may have physically tampered with it. I mean, I don't think that would be super likely, hopefully, but you never know. Sometimes you can take the OSI model approach. You can either do it top to bottom or bottom to top. And just kind of take the problem one layer at a time. Again, to just try to zero in on it, really focus on where it could be coming from. In the presentation layer, you may find something like the encryption between your application and your server. In your session layer, you may have a blocked port on either your host or your server. And then on the transport layer, you can have heavy network traffic itself. The network layer, you have your IP addressing information. If any of that's misconfigured, obviously it's not going to have internet connectivity, or whatever you're trying to connect to is probably not going to work properly. And you've got the data link layer. You have to consider if the MAC address of a machine could be blacklisted, or maybe it just needs to be whitelisted. Maybe you have it set to only explicitly allow connections from certain MAC addresses. And then you've got the physical layer, which could be bad cables, connectors, it could be a physical device that's malfunctioning, something could be overheating, anything like that. And you want to test your theory, and you want to try to test each theory you have without changing anything so that you can kind of confirm it. And then you kind of start to realize the problem is beyond your means, your boundaries. You might want to escalate the problem to somebody who may know a little bit more about it than you do. And then you have to establish a plan of action. Again, just write down your steps to resolve it. And you want to consider what the potential effects of your actions may have, because you may think something fixes the problem, and sure it might, but what if it breaks everything else? Obviously that's less than ideal. You want to implement your solution. This can be anything from educating an end user on how to resolve the issue themselves. Maybe it's just you have to press the power button. That happens an unbelievable amount at my work. I get people come up to my desk all the time, hey, my computer doesn't work. Have you tried turning it on? Oh, no, I didn't try that, thank you. So yeah, actually that resolves the problem probably 9 out of 10 times. And then maybe you have to install Windows updates, software updates, anything of that nature. You can always throw things out of compatibility. Maybe you want to replace any bad parts that you may have found. Maybe you have a memory tester or something. You tested the RAM, it's bad, or you got a deep code, something like that. And you want to try one solution at a time, just so you're not throwing everything at it, and then you're like, oh, well, I don't actually know what solved that problem, but one of it did, so all's well, right? But you may have wasted a lot more money on parts or time or whatever, when it really could have been just one simple thing like pressing the power button instead of rebuilding the whole PC. And then after you're done, again, you really want to document everything very thoroughly. You want to make sure, again, the problem, the solution, and the steps you took are all documented, just in case it ever happens in the future, so you know exactly what needs to be done. And then that's basic methodology to how you would go about troubleshooting really any problem, not even necessarily a network problem, other than the OSI part. But you also have various tools at your disposal that you can use. Windows has its own built-in troubleshoot problems, diagnostics on most things that they have on the operating system. They might not all work too well, but they can at least get you started, and sometimes they do resolve the problem. You have command prompt itself. You have third-party programs like Wireshark and Nmap, which might just help you get a better, bigger picture of a problem, in Nmap's case at least. And then you have your physical tools like your toner and probe, your cable testers, certifiers, multimeters, anything of that nature. And more on troubleshooting with command prompt, you can use commands like ipconfig. You have your optional switches like /all, renew, release, flush DNS, all that good stuff, so you can kind of tamper, well, I say tamper, but /all is more about figuring out your IP addressing information, and then you can renew it if you need to request a new IP. Typically you would use release first to give your old IP back, and then if you think you have maybe some kind of DNS issue, you can use flush DNS to clear your DNS cache, and that just makes it to where websites can't just pull straight from memory, and it actually has to go through your DNS server. And then you can use a ping test to test where you can go. You can ping your own interface card. You can ping other local machines on your network. You can ping outside your network. And each of these things would just tell you a different point of failure, basically. And then you have trace route, which is similar, except it tells you each hop along the way to the destination. So maybe it's not your network or even your destination network, maybe it's something in between. And then you have netstat, which shows you more detailed information about your current network connections. These are your active connections for the most part. It has things like your protocol type for your connection, your IP addressing information, and the state it's in. We have DNS lookup, which is name server lookup. You can find out if your DNS is working. You can basically use it the same as a ping, except instead of pinging an IP, you resolve the domain name itself. All right. And I have a short video explaining Wireshark to you a little bit.
Hello everyone. Now let's talk about Wireshark. So Wireshark is most popularly used a network protocol analyzer. So with the help of Wireshark, we can capture the internet packets which is going in and going out from our system. So it's the most popularly used software used for capturing the internet packets, mainly TCP/IP internet packets. Now let's see how we can capture some packets by using Wireshark.
Now let's see how Wireshark works. In order to start Wireshark, we have to start our Kali Linux, and even if you want to use Wireshark in Windows, you can download Wireshark from their official website, but in the Kali Linux, it's already installed. So in order to run Wireshark, open the terminal and write down here Wireshark and hit enter. So every time you run the Wireshark, this error will come, so you have to ignore this. Okay, so well, I told you earlier that Wireshark can capture the packet on a particular interface. But what's the interface? What is the interface? So interface is nothing but just your internet connection. So if your Kali Linux is installed in VirtualBox, then your interface should be ETH0. And if you have connected your Kali Linux through your Wi-Fi, then your interface should be WLAN0. And if you want to sniff the packets to the local host, then you have to select this interface, loopback interface. But right now, my Kali Linux is actually connected with the ETH0 interface. So here you can see the activity that the packets are coming, going in, going out. So you can see a little bit activity here at ETH0. Now, in order to sniff the packets or to capture the packets on this interface, you have to select this. You can just click over here, this icon. Otherwise, you can just double click on this interface. So as soon as I double click, here you can see the list of packets which is going in and going out. The result you can see is actually divided into different columns. Here you can see the number of packets, their time and destination, that way they are going, and the protocol which they are using, and information regarding a particular packet. Now just for example, let's ping google.com and we'll see the packets which is coming in and out, and these packets are being captured by Wireshark. And if I scroll down, you can see the packet echo ping, ping request and ping reply. So this source, you can see a source here. This is my Kali Linux IP address, and this is the destination IP. So this is the IP of google.com, and the protocol is ICMP. And in order to find or in order to read a detailed information about each and every packet, just select that packet, and here are some packet header information. So it's frame, Ethernet header, internet protocol. So let's read this. In the internet protocol header, you can just check the source address and the destination address, and the destination GeoIP location also, the location of google.com or the location of this IP, United States. And in the last, there is a header of ICMP also. You can check the ICMP protocol header. So it's a type 8 header, and here you can see echo ping request. And if I scroll down, you can just also check the timestamp and also data which is coming in and out, and the size also 48 bytes. Here you can see the data and its length. And at the bottom, here is some hex values you can see. So actually this data is present in the hex values. So the work of Wireshark is to parse this data of hex data, to parse the hex data into this text one. So even if you just select any part of hex data, you can see that that part of text will automatically selected. If I just click over here, you can see. So this is how you can use Wireshark to capture.
Alright, so I think that gave you all a good little idea of how Wireshark could be used. Just gives you very detailed information about incoming and outgoing packets on your network. And then you also have things like InMap that you can use, which is a free network mapping software. It uses packets to determine what hosts are running on the network, as well as what services they may be offering. It kind of probes it. It's useful for things like taking inventory of your network, because it'll kind of tell you everything you have on it. And it's good for monitoring uptime of various devices, because again, it's kind of an overview. You can see most everything at once. And then you have maybe physical problems, maybe your computer caught on fire, in which case you might want to consider replacing it. You have open circuits, short circuits, improper wire mapping as far as cables go. You might have crosstalk on your cables, noise, signal loss, maybe if you're doing something with video, and then maybe something's unplugged, maybe something's turned off. Could be any of these things. Maybe somebody's running down a set of stairs. You never know. You would have about that last one. And then to wrap everything up, you kind of, when you're network troubleshooting, you want to follow your troubleshooting process, because it'll really help you in staying organized when you're looking to solve your problems. You have to figure it out and everything, and you want to do everything in as orderly as you can. And you want to use every resource you have available to you, maybe the customer's initial information. You want to use your software utilities, your hardware tools. As my Indian tech friends always call it, you can utilize your senior resources, which is probably some guy in America. And then you want to keep careful documentation on the solution and the problem. And you also want to make sure you implement your prevention methods as far as educating or installing updates or whatever the case may be. And then really with networking and everything like that, there's no fix-all to anything. It's not everything is as simple as duct tape. As you can see there, somebody has duct taped an airplane. It's not really recommended you try something like that. That pretty much wraps everything up. Does anybody have any questions or comments? No? All right, well, thank you.